Okay, so the velocity time graph here. What we need to know is that for the first 10 seconds, the velocity stays the same. So the distance will be given by velocity times time, which is 20 times 10, which is 200. So we should have a line going all the way to that point there. So I'd expect it to go like that. You should use a ruler for this. Then between 10 and 15 seconds, the velocity drops. It's decelerating. Okay, it's decelerating. The distance of travel, again, is velocity times time. So it's 5 seconds. The velocity is 20 seconds, but it's a triangle. If you notice, this triangle is not a rectangle from there to there. So the area of that triangle is velocity times time, and that works out at 50 meters. So we know it's going to go to 50 meters around there. And we know the velocity is changing, so we should actually draw it as a slight curve. Okay, so it'll be a curve. I'll try to get this round to there. It should be a curve to there. Smoother than I've done there. Right, and then at that point there, the velocity is 0 for a while, so it shouldn't be increasing velocity in displacement. But we know that for the next 10 seconds, it goes down to 5 meters per second. So 10 times 5 is 50, but it's half, because again, it's a triangle. Okay, so that's going to be 25 meters. So I need to go 225 after that distance there. So that's where it's going to be at that point then. So I'm going to draw a nice little curve around to there, because it is a change in velocity. And then a deceleration after that for the next 15 seconds. For 15 seconds from here to about here. 15 times 5 is 75. So that's 75 meters we got there in that area there. This area here is 25 meters. This area here is 50 meters. And this area here, 20 times 10 is 200. So 200 is there. So this final bit is going to drop 75 meters, which should take us to 150. And that's at the end of the journey. So we should get a straight line going from there to there. Okay. So in reality, it probably looks straight, then curving around, and down to those values that we've written down there. It's important you get the distances right. Use the grid to sketch an acceleration. Right, so initially there's no change in velocity, so there's no acceleration. So from here to here, there is no acceleration. Okay, at 10 to 15, it's gone from 20 to 0. So there's been a change in velocity. Acceleration is the final velocity, take away the initial velocity, divided by the time taken. So the final velocity is 0. The initial velocity was 20. The time taken was 5. So that gives you an answer of -4. Okay, so that will go down to -4. And it stays like that for 5 seconds. So it goes along to about here. At this point here, we've got the velocity. Initial velocity was u. The final velocity was -5. So that's -5 here. The initial velocity was 0. The time taken is 10 seconds. So the acceleration is -5. That's going to be basically our acceleration of -0.5. So after 5 seconds, we go to about 0.5, which is about here. And that goes for 10 seconds from there to there. So it goes from here upwards like that, there to there. And at 25 seconds, if you notice, the velocity does not change. Therefore, there's no acceleration. So it should go from here all the way back to here's a straight line. Okay, that's what it should look like. Right, the total distance the car travels, basically use what I've just done here, is you work at the area under each one of these. Now, displacement is a vector. It has direction. So if it was a displacement, it'd be 150 meters. We've worked it. But distance is a scalar. So basically, you have to add all these things together. 200 plus 50 is 250, plus 25 is 275, plus 75 is 350. And that is the end of that worksheet.